اوكي طيب الان نبدا بشابتر 2 يا جماعه. شابتر 2 موضوع سهل جدا، هو التايتل تاعه System Modeling in the Time Domain Continuous Time Systems. طبعا احنا هون شابتر 2 بالتكست بوك تاعكم، يمكن انا استخدمت ترقيم مختلف ولكن هو شابتر 2 in your text book اللي هو System Modeling in the Time Domain. طيب systems are designed to achieve certain task. اذا احنا قلنا السيستم ايش بعملوا انا سيستم to achieve a certain task. والsystems operate on one or more inputs to produce one or more outputs. اذا بدنا نتخيله اكثر يا جماعه نتخيله كالتالي. عندي انا هي سيستم، عندي سيستم بدخل له input voltage or current، بيطلع لي هون حراره. اي سيستم هذا الكتريك هيتر، انا بدخل له فولتج هون او كرنت، بتحكم في هذا السيستم، بدي يرفع لي الحراره او ينزل الحراره. اوكي اذا الانبوت سنجل انبوت سنجل اوتبوت، سنجل انبوت سنجل اوتبوت. وايش الاتشيف تاسك هون اللي هو ايش تعمل؟ temperature. اوكي now we usually use the following notation for a system to describe a system. we use the following notation. هذه النوتيشن اللي بنستخدمها انه x of t input y of t is output. السيستم in a box، وبنقول انه transfer لانه you transfer the input to output. you make an output from the input. it's like a transformation. okay it's like a transformation. since you are making transformation so we use letter T. transfer هنا اللي هو البراكتس هذول square brackets، بتحط ال x of t جواهم بيطلع y of t. اذا we can write y of t as a transfer of x of t. بندخل x of t as system and we achieve the certain task which we are interested in. In engineering the word system، كلمة system refers to the mathematical model or representation. نركز إنه شو mathematical model or representation. very important. إنه system معناته or we refer to as a mathematical model or representation. إذا كلمة mathematical model or system all they have the same meaning. إذا system هو نفسه mathematical model or model. Let's consider the following example. نشوف the following example نربطه مع السيركت. السيركت اللي اخذناها بالكورس سيركت. طيب simple electric circuit عندنا هون input voltage source، هي voltage source، عندي output V out. انا الانبوت تاعي الانبوت هو الفولتج انبوت والاوت هو V out. هون عندي RC circuit، simple RC circuit. هون طلعت جوا البوكس حطيته، هذا هو السيستم، بدخل له الفولتج بيطلع الاوتبوت V out. اوكي العلاقه هلا بدنا نشتق. احنا قلنا انه هو السيستم نفسه هو نفسه الماثماتيكال موديل. طيب بدنا نقنع نفسنا بهذا الكلام. هذا سيستم الان بدي اشوف الماثماتيكال موديل كاركترايز ذيس سيستم. اوكي الان اي اوف تي، هذه اي اوف تي اذا متذكرين اي اوف تي شو علاقتها مع في اللي على الكاباستر؟ ايش علاقه الاي مع الفي؟ كلنا بنعرف انه العلاقه هي تساوي اي اوف تي في الكاباستر تساوي سي multiplied by the derivative of the voltage across this capacitor. The derivative of the voltage across this capacitor, multiplied by the capacitance equal the current. Okay. Now, VC هذه VC إذا عملت KVL هون VC، هي VC، حط VC، هاي VC. أوكي. إذا عملت KVL هون بلاحظ إن ال VC هي الديفرنس بين VN and V out. KVL simple KVL بنشوف إنها VC هي difference between the input and the output voltage. right? الآن بما إني أنا قلت VC is a difference, then I immediately plug this difference here. هاي VC، هاي VC. I plug it here. Okay. Just hold on a second. طيب إذا VC هي difference between the input and the output voltage. Just plug it here. بتصير IC هي CD over DT لمين؟ للVC اللي هي difference between the input and the output. Okay. Also, if you know that, لو سألتك what's the relation between V out and I؟ هو I هذه series. إذا I هذه هي نفسها I هون، والعلاقة في المقاومة هي linear. يعني V تساوي R في I. V تساوي R في I. اوكي V اذا I هي V out على R. Great. الان just plug it here. اوكي the value اللي هي I تساوي V out على R، ووزع الديريفاتيف، ونوزع الديريفاتيف وبنرتب الايكويشن هذه. بنلاحظ انها الايكويشن ترتبت بشكل ممتاز جدا. صارت دي في اوت على دي تي 1 على ار سي في اوت تساوي دي على دي تي للفي ان. اذا بنلاحظ انها العلاقه هون، هذا الديفرنشال ايكويشن او الماثيماتيكال موديل. لما انا قلت لك السيستم هو نفسه ذا ماثيماتيكال موديل، بالفعل احنا جبنا العلاقه هذه من السيستم. اذا الماثيماتيكال موديل characterize the system. اذا كلمه system or model they have the same meaning, they have the same behavior, okay, they have the same effect. اذا هون ربطنا، لاحظ ال V out ربطها مع ال V in by differential equation. اذا الانبوت V in والاوتبوت V out. اذا هذا السيستم موديل لو اعطيتك يعني الماثيماتيكال موديل او اعطيتك السيركت المرسومه فوق they have the same meaning. اوكي great. واضح؟ Note that the mathematical model relates the relation between the input and the output as I mentioned earlier. طيب هلا how to connect these systems؟ لان احنا قلنا السيستم موجود، ولكن احنا دائما احنا قلنا we describe the system as a simple or a simpler systems حتى نقدر نفهم كيف السيستم behaves. Okay? So we mentioned earlier the complicated system can be decomposed into a set of connected of similar systems. هلا نشوف كيف how do we connect these systems. Okay? The complicated system we try to compose it into a set of or connected similar systems. نشوف the possible ways to combine these systems or to connect these systems. We show below some of the simple system used in practice. هات نشوف شو هم. أول شيء اللي هو summing junction. Easy summing junction. signal داخلي واحدة اثنتين. هذا we can imagine it as a system يا جماعة. This is a system. You just sum up all the inputs and you get the output. إذا summing junction to get the output you sum all the signals. هذا one way. Second way, okay. Second way to connect this system, you multiply. Product junction, we call it. Product junction. This is a system. You multiply x1, signal 1, with signal 2, and you get the output. Or the third one, you scale, just to scale, a kind of scaling, okay, this signal, and the system is just scaling the input, and you get the output. Alpha x of t, scaling junction. Okay. Now, there are several ways system can be connected, okay? The two most common ways are series and parallel. Series and parallel, two ways to connect these systems. هات نشوف مثلا parallel connection. هذا parallel system 1 and this is system 2. Okay, system 1 and system 2, and there is the input and here's the output. نلاحظ الاوتبوت هو السم. This is summing junction. Okay, it adds the output y1 and the output y2. So it adds y1 plus y2. Okay, what is y1? What is y1? تساوي transfer function. قلنا we describe the system as a transfer of x of t. X of t. y2 the same way. y2 تساوي transfer of x of t. إذن ال y overall هي sum between the transfer of the two systems to the same signal. هذا parallel connection. نشوف السيريز. Series connection. عندك one system and the other system. Okay. One system. This is one system. This is the other system. The first system has y1. What is y1? It's the transfer of x. But what is y? The overall y. It's the transfer of y1 as an input. Then we can write the system as transfer 1 of x of t. And this is transfer the overall connection, transfer the x of t into y of t through two systems, series connected systems. This is just kind of simplification the system in order to understand how the system behaves. يعني decompose the system حتى تقدر تدرس كل part as an easy system. Okay. ناخذ example. Consider the following system. أن هذا system شوي complicated. تخيل لو بدك تدرس interrelation between the input, okay, the input, هاي الانبوت, and the last output. It would be a little bit complicated. So we try to decompose the system into easier operations. Sum, multiplication, look, multiplication, okay, or scaling, and sum, scaling. Okay, here is some junction. So we try to simplify the system as much as we can, so we can figure things how are going inside. Okay, so this is a system. We can see that there's x of t input, and there is here a scaling. This is a scaling. Okay, you get x1 as an output to t1. It's a multiplication. Then t2, system 2, you get x2. It goes to the summation here, and x of t, it comes immediately to the sum as a difference. Okay, and then you get x3. X3 gets in to the system 3, and then summed up, and here. So you have to follow up. Let's see how things are going. إذا بقول لك هون السيستم T1 هيدا T1 هيو T1 is just a scaling. يعني y of t الاوتبوت تاعه بيضرب by 10, multiply the input by 10, value 10. System 2 multiply by 2 and take the squarer of the input, of its input. T3 هو y of t يساوي 4 and here delay. هذا بيعمل delay by 3. هذا squarer. اوكي وهذا scale. take the scale. اوكي وهذا شو بيعمل نفس السكيل. يعني احنا قسمنا الكومبليكيتد سيستم into squarer, delay, scale, different way. Okay, just immediately you try to substitute the inputs and you get the outputs. هي مكتوب كله موضح. Okay, I leave it for you. And then you get the overall response اللي هو y of t last one بيساوي هذا. تخيل.
مش هذا الحياة يا فاطمة.
هذا بيطلع اللي هو y of t last formula. هذا الموديل. هذا الماثيماتيكال موديل تاع the system, overall system. هذا الموديل for the system, the overall system. Okay. Now نروح على more important for us اللي هو system modeling in time domain. Okay. عبد الخالق لحظة نشوف عبد الخالق. طيب system modeling in time domain. System modeling in time domain. The model term is used to refer to a set of mathematical equations. قلنا إنه الموديل هو نفسه mathematical of equation used to represent a physical system. إذا إحنا physical system we try to express it in terms of mathematical equation. The model حكينا إنه relates the system output to the system input. هذا الموديل. Okay. Now the model is needed. Why do we need the mathematical model? Why do we need? We ask ourselves, why do we need a mathematical model? One answer, we need to understand the system behavior. يعني مثلا بدي اشوف بدخل عليه step function اعمل switching. مثلا انت عندك بدك تضوي الضوء عندك في البيت بدك تشوف البيهيفير. اذا رفعت المفتاح لفوق مثلا بيضوي لتحت. اذا you try to figure out the system behavior. كبسه الضوء عندك بدك تشوف الى لفوق بيضوي ولا لتحت. You try to figure out. وهذا you can do it in mathematical model to figure out things how are going. Okay. The other thing to understand whether we can design a controller or not, and how to design a controller for the system. Okay. To make sure the system is stable. مثلا how to make sure the system is stable. You need to understand the behavior of the system. Okay. Then that's why we try to model the system. The system is a quantitative description. The definition of a system is a quantitative description of physical process. Quantitative description, okay, which transforms signals at its input to signals at its output. هذا السيستم اللي هو بيحول بترانسفير the system from the input to the output through the system. نشوف the properties of the system. البروبرتيز of the system. أول property if the signals proceed السيجنالز اللي داخلي هون إذا السيجنالز يا جماعة اللي processed by this system okay إذا الانبوت or الانبوت signal والاوتبوت signal اللي processed by this system is discrete or continuous signal okay continuous بسميه continuous time system. إذا السيجنالز اللي بيعمل عليها البروسيسنج continuous then I call it continuous time system. If the signal input signal discrete or the process signal is discrete then we call it discrete time system. إذا هو بياخذ اسمه من نوع السيجنالز اللي بيستخدمهم اللي بيعمل عليهم البروسيسنج. إذا if the system okay if a signal preceded by a system are continuous time signals then the system we refer to as continuous time system. If signals preceded by a system are discrete time system then the system is discrete time system. لأنه أنتم متذكرين كنا عملنا أو طلعنا على خصائص أو classification للسيجنالز في chapter اللي قبله 1. قلنا في عندنا discrete time signal وفي continuous time signal في عندنا even signal و odd signal في عندنا periodic signal فعندنا طلعنا على كل الكاركترستكس اللي ممكن السيجنالز تختص فيهم. فهون نطلع الآن على السيستم دور السيستم نشوف شو الخصائص اللي ممكن هو او البروبرتيز اللي ممكن نعمل كلاسيفيكيشن للسيستم بناء عليها. لانه نشوف بعض الخصائص المهمه جدا to classify the systems in order to be able okay to work with these systems. انت اذا بدك تعرف تتعامل مع شيء لازم تعرف خصائصه قبل ما تتعامل معه. فاحنا الان we need to classify the systems into certain properties. اذا similar to signals systems can be classified into several types based on their properties. Some properties are desirable for specific applications. Example, where are some applications? For example, system that require memory, system that requires memory, you immediately will know that you need capacitors and inductors. ليش؟ لأنه they store energy. عرفنا نعرف الكاباستر والاندكتور they store energy. بينما الريزيستنس it doesn't store energy. So it doesn't have a memory. إذا الاندكتور والكاباستر they have memories. Then you know which element to choose to design your system if you know the properties of the system. Okay. Now we can explore such properties. Let's start exploring these properties. Okay. أول واحدة بنسميها system with memory. System with memory or memoryless system. إنه السيستم فيه ميموري بيحتاج إلى memory or it doesn't have. أول خاصية هي أول characteristic we can classify systems into memory or memoryless systems. Okay. A system has a memory. نشوف شو تعريف الميموري. نشوف what is the meaning of when the system has a memory. If the output at time t node, any time t node, take any time t node, call it y of t node. The output at t node depends on the input values other than x of t node. إذا وجدت إنه y of t node عند أي لحظة بيعتمد على شيء other than x of t node الانستنت t node من الانبوت then the system is memory. سواء كانت on future value or past value. يعني إذا دخل في تحديد قيمة y of t يا جماعة، إذا دخل في تحديد قيمة y of t أي value من الانبوت other than the present value تاعت الانبوت then the system is memory. سواء كانت من الفيوتشر or من الباست. Such system with memory is also called الميموري system. signals السيستم اللي له memory we call them they are dynamic systems. dynamic لهم اسم ثاني dynamic systems. كمان مرة what is the meaning of memory system؟ إذا دخل في تحديد قيمة الأوتبوت at the present value الأوتبوت any value other than the present value of the input then the system is memory. And we sometimes call it dynamic system. other than this it is called memoryless. طبعا اذا فقط كان بيعتمد على present value للانبوت، اذا كان الاوتبوت بيعتمد على present value للانبوت it is called memoryless، ما بيحتاج الى memory. Or without memory system, or we call them instantaneous systems, or we call them static، لانهم قلنا dynamic هون عكسه static. It doesn't need memory. هات نشوف example. حدا عنده استفسار قبل ما نكمل؟ نشوف example آخر، أو نشوف أول example. sorry. Let's see the first example. Example of a system with memory. الانتجريتر شو رأيكم؟ هل له memory ولا it's a memoryless system? Let's see your response on the chat. حدا يكتب لنا هل هذا memory or memoryless الانتجريتر. What do you think؟ هذا y of t output you take the integral of the input. memory يا اسلام صح؟ غيره memory ولا memoryless؟ memory. ليش memory؟ قلنا اذا بده يكون memoryless لازم في تحديد y of t فقط يدخل قيمة x of t at that instant. بينما بنلاحظ احنا هون حتى احصل على y at t مثلا، اوكي، او لو حطيت هون t نود اي لحظة من الزمن حتتعوض t نود هون تصير t نود. اذا بتاخذ انت الباست ريكورد، بدك كل الباست ريكورد لانك من ماينس انفينيتي to find the present value of the output. اذا you take the past record of the input plus البريزنت اللي هي x of t y x of t نود البريزنت، وبالاضافه لك بتاخذ البريفيوس ريكورد او الباست ريكورد to decide the value of x of t or sorry y of t at t node. The same applies for voltage across capacitor. So the integrator is a memory. Okay, the system هذا system integrator بتدخل الانبوت سيجنال بيعملها انتجريشن وبيطلع الاوتبوت. So هذا is a memory system. Is it clear? Let's proceed. Example. خلينا نشوف هاي مثلا. Y of t equal k constant multiplied by x of t. Is it memory or memoryless؟ memory ولا memoryless؟ شوف جاوبونا، شوف على الشات اذا سمحتوا. اذا متاكد انه memory اكتب memory، اذا انت you think it's memoryless let's see. طبعا dynamic وstatic كمان، كلمه dynamic for memory وstatic for memoryless. instantaneous for memoryless as well. memoryless. ليش memoryless؟ لانه take any value here xt node اي x of t node اوكي، وعوض تطلع معك تعتمد فقط على present value. إذا you need the present value of the input to decide the value of the output. Okay. إذا static or instantaneous system. نشوف الثاني هذا y of t the squarer. هذا squarer system. You take the input and you take the square value of the input. Let's see if you find at y at t node, then the same. It depends on the present as well. So the output depends only on the present value. Doesn't need neither future nor past value like the integrator. Type. Let us proceed. Example. Another example. What do you think of this example? Y at t تساوي x of 2t. Is it memory or memoryless? Let's see. Let's take any value. Take, let's say, y at t node equal 2. Then y at t node equal 2 تساوي x at 4. So this is a future value. You can see this is a future value. It participates in the this or to decide the present value of the input. انت هون present and 2, and you take from the future value to decide the present value, which needs memory. It needs memory. طيب وضحت موضوع الميموري ان شاء الله؟ اوكي. hopefully هنا واضحه. Chris, you can go. Okay, you can carry on. You have something.
بس ممكن تعيد عن الميموري والميموري ليس، مش واضحه.
اوكي حاضر. كمان مره انه to find whether memory يعني انت if you need to process something نيجي على الكمبيوتر engineering if you need to process something you need values from the past to process something now you need something from the past then you need memory okay you need memory or you need to process something and you need something from the future so you need to wait for the future and give this data put them in a memory and then do processing so إذا you are doing instantaneously يعني إذا أنت مثلا بيدخل عندك الانبوت now and you take your decision based on the present input the present input you take your output based only on the present input then you don't need memory there's no need for memory كمان مرة if the output only depends on the present value of the input then you have no memory at all no need for memory whereas if you need future value of the input or past value of the input to decide the value of the current or present output, then you need memory. That's it is. Okay? Hopefully it's clear. Type. Note that now, note that some definition applies for discrete or same definition applies for discrete time systems. إذا شو discrete time system كلنا احنا حتى نمثل الديسكريت تايم حتى نمثله ونميزه عن الكونتينيوس تايم اذكركم شوي لحظه فيه اذا تسمحوا لي خليني اذكركم اللي هو نيو شير اوكي وايت بورد اوكي اذا اذكركم انا لما عملنا مثلا سيجنال في السابق هي سيجنال عندي هون قلت انا هذه continuous time signal continuous it's defined on all the time domain هي معرف عند اي لحظه من الزمن هذا continuous time قلت اذا انا بدي اعمل منها discrete version وقلنا we refer to this signal as x of t هيك حتى نميزها اوكي قلنا اذا بدي اخذ منها انا discrete اذا بدي اعملها discretization حتى ادخلها على الكمبيوتر شو بعمل sampling متذكرين sampling شو بيسوي sampling عند every instant you take the value you take value عند كل لحظه بتاخذ عند كل مثلا بيريود معينه بتاخذ value بتدخل هذول اللي بالاحمر بدل ما تدخل السيجنال كلها هذول كلنا بنعبر عنهم حتى نميز انه هذا discrete time لانه معرف عند discrete n plus 1 n plus 2 معرف فسمينا هذا x of n اوكي وسكوير براكت حتى نميز الديسكريت عن الكونتينوس هذا continuous time هذا discrete time signal حتى نميزهم قلنا احنا we take different notation هذا different notation اوكي كل اللي احنا درسناه so far applicable for discrete time signal as well okay same definitions apply for discrete time system اوكي هاتوا نشوف شو ناخذ example اسمحوا لنا ناخذ example هون نسمحوا لنا ناخذ example note that okay example عندنا هذا squarer y of n you take the square value of the input it is memoryless ليش؟ لأنه take any value n node مثلا y of 2 تساوي x of 2 it depends on the present value إذا it's memoryless ما بيحتاج إنك تخزن values from the past مثلا or from the future طيب ناخذ هذا السيجنال مثلا y of n equal x of n plus x of n minus 1 هل هذا memory ولا memoryless؟ شو رأيكم؟ memory ولا memoryless؟ طبعا memory ليش؟ ليش يا أحمد؟ ليش memoryless؟ في past exactly في عندنا past
لا دكتور أنا عندي سؤال كيف بدي أخزن من الفيوتشر؟
ما بدك تخزن اوكي السؤال ما بدك تخزن من الفيوتشر هذا متذكر شو قلنا احنا السيستم له اسم ثاني الميموريليس انستنتينيوس سيستم بينما هذاك بنسميه اوف لاين سيستم يا مين سأل؟
احمد
هذاك السيستم اذا انت بدك شيء من الفيوتشر you call it offline system شو يعني offline you have to wait until you receive all the future values and then you start doing processing okay you cannot do it online you need to store all the values from the future or from the past and wait until all the values you get all the values and then you start processing. So this is offline system, we call it. Okay? This is another name. It's a memory system. We can sometimes call it offline if you are looking for the future value. Hopefully it's clear. نشوف هذا السيستم بالديسكريت تايم.
يسلم دكتور يسلم.
y of n equal x of n plus x of n minus 1. تعال خذ اي فاليو x y of n at 0 عند لحظه الصفر بنلاحظ انه اوكي هذه present value, it's fine so far. بس هذه من وين؟ من الباست. اذا you need memory, you need to store these value. So it's a memory system we call. System needs memory. Okay. Let's carry on. Okay, let's carry on. Okay, هون عندنا الكاوزال سيستم. Causal system and non-causal system. هذا system is linked to the memory system in somehow. The memory system, if there is anticipation from the past or from the future, then the system is memory. Oh no, you can anticipate from the future and the current value, okay? And this is, we call it causal. If you anticipate from the future, then we call it non-causal. All right? نشوف هنا a system is said to be causal if the output at any time depends on the input value, which are at that value or less. يعني past and present. نسميه إذا اعتمد على ال past or present value of the input, then it is a causal. Otherwise, it is non-causal system. Or another way, if the system only responds when you kick it, another meaning. Or if the system cannot anticipate future inputs. إذا ما في anticipation from the future inputs to decide the present value of the output, then the system is causal. Now, all physical systems are causal system. This is an argument. In all physical systems, they are causal system. What do we mean by physical system? The systems which process in real time processing. So no future values are available. دايما انت you have current values and past record. You don't have future values. وعلم الغيب. So all physical systems, they are real system and they do not anticipate the future values. ناخذ example. Let's see this example. X of t equal half x of t plus, y of t equal half x of t plus x of t minus 1. This is a causal system. Why this is a causal system? Take any value here, take 1, let's say, or 2, or 0 at t. You see here it is 0, present value. You decided here minus 1, so it's past value. Okay, this is the past value. This is a causal system. No future anticipation. Doesn't depend on the future. Another example. Here it is. Example, y of t equal 1/3 x of t minus 1 plus x of t plus x of t plus 1. This is what we call it a moving average filter. That is a low pass filter if you want. Okay, because you take the average value of the present value. Okay, you take the present value, the average value of the present and the past and the future, and divide it over the number. This is a kind of averaging. If you want, you can just test the point at t equals 0. Here you see it is t minus 1. This is at 0. This is at plus 1. So this is a future, the future anticipated. So this is an non-causal system, and this system doesn't work in real time, and it's an offline system. You have to wait all the symbols you receive, and then you start doing a kind of processing. So this is a non-causal system. Example, more examples. Here I have another example. Y of t equals 3xt. Just take any value here. You will see this is a future value. So it's a non-causal system. And this is another one, square of the time. It's a non-causal as well. Just substitute any value. You will see it's a non-causal system. And here we have this differential equation. It is a non-causal system. Or so it's a causal system. It doesn't depend on any future value. Okay, But if let's say you have like this minus infinity to t, still it is causal. But if it's t plus 1, so you are looking for, so you are looking here, just a second, you are looking for future value, so it will be non-causal in this case. Okay, let's proceed. Here, all same thing applies for discrete time systems. Same thing, same definition we have adopted before, it applies for discrete time systems. Look at this example, system 1, we have a system 1, it's a moving average system, okay? It's a moving average system. It takes the present, past, and future value, discrete time, to decide y1 at n. Now, if we take y1 at n node, okay, so this is y, the output. Okay, we can see that it depends on the past, present symbol of the input signal, and the future. So this is a non-causal system. In another way, you can see this system, system 2, here system 2, 1/3 x of n minus 2. This is past, this is past, and this is past value, and this is present. As it is a causal system, you can see it takes only the past record and the present value, doesn't take future, no future anticipation. So this system is causal. So there's a difference between when you are considering future values to decide current output, and if you don't care for the future values to decide current input. And here arises the definition of causality. Okay, let's come to the time invariant and time varying system. This is very important. This is very important, okay, property of systems, because we will see later on most of the processing we are going to do on signals, they're based on time invariant definition. So when you know this is a time invariant system, we have a different way, okay, to work on these systems. If it's not, there's completely different procedures to deal with such systems. Okay, now let's see this. What do we mean by time invariant and time varying system? ببساطة, time invariant, it means it doesn't care for the origin. يعني, if you apply the input at any time, or if you apply a distinct input, okay? So, I mean, what do you mean by that? If you apply a distinct input at time, then there's an output. If you apply the same input at any time, shifted time, you will have the same output shifted. This is what we mean. So a system is time invariant if time shift of the input signal results in the same shift of the output signal. Yani if you apply x of t to the system, you will get y of t. If you apply x of t at later time or previous time, shifted time, you will get the same output shifted. So it doesn't care for the origin. Another definition. That means the system doesn't really care what you call the origin. Okay. In another way, it says that if you take the input and you shift it in time, shift it in time, okay, the result is the same as if you take the output and shift it in time by the same amount. This is another explanation for the time invariance. Systems, now in another way, systems whose behavior changes with time. If the behavior of the system changes with time, then we call it time varying system. Yani if you apply the input, distinct input now, okay, you will get an output. If you apply it after 1 hour, you will have maybe a different output. This is what we refer to as time varying system. It changes its behavior depend on time. All right. So a time varying system has properties or characteristics that vary with time. This is what we mean by time varying system. Let's take the example, or let's see the procedures to test whether this is a time varying or time invariant system. The procedure, let's take this example, y of t equals sine of t. This we call it modulator system, You just multiply, Okay, this is the system. Whatever in the input, you will multiply it by, okay, let me just explain it. So it's a multiplication system. Whatever you have in the input, x of t, okay, you multiply it by sine of t if you like, and you get the output. You get the output. Okay. So procedures to test whether this system a time invariance or not. Let's see what are the procedures. The first step, take any signal, let input be x1, any input. Then immediately you will decide the output, which is y1 of t equals sine of t multiplied by x1 of t. Step 2, let input be x2 of t, a shifted version of x1, just a shifted version. Make another input, which is a shifted version of the first input, and find y2, the corresponding output. So y2 of t, the corresponding output, equals sine of t multiplied by x2 of t, and x2 of t, it's x1 shifted. So this is y2 of t. Great. Now what we want to do, we need to determine, okay, this input, if we shift it, the output, if we shift it by t minus t naught, what is the value? So we know y1 was sine of t multiplied by x1. Make a shift on the output. Make a shift on the output. Okay. And this shift applies for t. So this is y1 shifted. Y1 shifted. Great. Y1 shifted and y2 corresponding to the shifted input. Or y1 shifted. This is y2 corresponding to the shifted input. If this one equal to this one, then you have time invariant system. Let's test. Are they equal? They are not. So it is time invariance. So the system is time invariance. Sorry, it's time variant. Time varying system. هنا غلط إنه time varying. Okay, no, it's correct. It's correct. This is the condition. If y2 equal y1, the system is time invariant. Since they are not equal, then the system, it's written here down, the system is time varying system. This is the way how you test the system, whether it's variance or invariance. There's another example here. I leave it for you. We can see this is a time invariant system. You just follow the procedures. Another way to imagine the solution, or another way to test whether the system is time invariance. This is another way. It's just like you can imagine, you just take any input. Okay, let the decide its output. Okay, and then make a delay on the output. So this is the delayed version. This is, sorry, here's a mistake. This is should be y1 of t minus t naught. Should be like this, not y1 of t. And this is it is what it is. And the same input you take first, make the, and here you input it to the system and take the delay. Here you delay it and then you input it, let it to the system, and you decide y2 if 2. If these both they are equal, then the system is time invariant. If they are not, they are not equal, and it is a time varying system. This is another way to test the system. First, input the system to the input the signal to the input, make a delay on the output, and input the system to the delayer, and then let it to the system, and you decide if they are equal, the two output, then it doesn't care for the origin, it doesn't change its behavior based on the time, then the system is time invariant, otherwise it's time varying system. And here the last argument, similar definition applies for discrete time system. Okay, with this we finish our class. Thank you for your listening and have a good day.